Hello everyone. In this video we see some basics of the theory of the computation, means TOC. So here is the first question. Prove the following principle of a mathematical induction for every n is greater than equal to 0. So first question in theory of computation may be asked prove the given equation. So how it is solved? So every time we follow only 3 steps. So first step 1, put n is equal to 1 at the starting of the solving question. Then step 2, put n is equal to k. And step 3, put n is equal to k plus 1. When we perform these 3 steps, we automatically prove our equation. How? Let's we see. So we write here solution. So our first step number 1, put value of n is equal to 1. So when we put the n is equal to 1 in the LHS, then the LHS is equal to summation of I is equal to 1 to n I square. So this is go up to 1, n is goes up to 1. So this is nothing but we write 1 square and 1 square is equal to 1. So this is the LHS. Now the RHS. So RHS is equal to, here is the RHS, n into n plus 1 into 2n plus 1 divided by 6. So we put n is equal to 1. So here is the 1 in bracket, 1 plus 1, 2 into 1 plus 1 divided by 6. So 1 into 1 plus 1 means 2. 2 into 2 plus 1, 3. So this is 2 into 3 divided by 6, which is nothing but 6 into 6 is equal to 1. 6 get cancelled. So here we can prove LHS is equal to RHS when n is equal to 1. Now we move for the step number 2, where we put the value n is equal to k. So first here write for the when n is equal to 1, that time LHS is equal to RHS. Now we write this step number 2. So step number 2, assume that n is equal to k. So again the LHS is equal to summation of I is equal to 1 to n I square. This summation of I square we write here means I start from 1, so I square plus 2 square plus 3 square up to n square. The meaning of this summation means this. So now we put n is equal to k. So we write this 1 square plus 2 square plus 3 square up to k square. So this is the LHS, and RHS is equal to n into n plus 1 into 2n plus 1 divided by 6. So when we put the value of n, so this is k in bracket k plus 1 in bracket 2k plus 1 divided by 6. So we combine both LHS and RHS when n is equal to 1. We write the equation 1 square plus 2 square plus 3 square up to k square. This is our LHS, previously we see, and the RHS we get k into k plus 1 into 2k plus 1 divided by 6. We now not prove the LHS is equal to RHS. When we put n is equal to 1, that time we prove LHS is equal to RHS. But when we move for the second step, that time only we write the equation in k form. So when we put n is equal to k, that time we write the LHS and the RHS in the k form. So we write step number 2 is complete now. Now we move for the step number 3. Step 3, put n is equal to k plus 1. So we put n is equal to k. We write LHS is equal to 1 square plus 2 square plus 3 square plus up to k square plus k plus 1 square. Now you all say, why we write k square plus k plus 1 only, why we not write k plus 1 square? Because we want to put n is equal to k, and our original equation is, as we all know, summation of I is equal to 1 to n, I square is equal to n plus 1 to n plus 1 divided by 6. This is our equation, and we put n is equal to k plus 1. So k square plus k plus 1, this is nothing but the 1 plus 1 2. Now 2 plus 1 3. So if we write k square plus k plus 1 square, so exactly meaning is the same. Let's suppose this is our 4. After the 3 square, suppose k is 4. So if we put here k is equal to 4, then this is the 4 square plus this is the 4 plus 1 5 square. So the meaning is not change our. Here our LHS is equal to I square, and this I is incremented by 1. So if we want to increment k plus 1, then previously k is mentioned. So k and then k plus 1. K is increases by 1. So that's why we write here k square first, then k plus 1 square, and is equal to k plus 1 into k plus 1 plus 1. This is the term of n, means n plus 1. So we put n is equal to k plus 1, and this plus 1 is here as it is, into 2 into k plus 1 plus 1. This term 2n means 2 k plus 1, and this plus 1 we write as it is, divided by 6. Now we simplify the equation. So as we know, we see here in equation number 1, the term 1 squared up to k square. See, this is equal to k in bracket k plus 1 2k plus 1 by 6 by this first equation. So we write up from the 1 square to k square, we write this is equal to that term. So we write here directly. So k plus 1 2k plus 1 by 6. I hope you get why we write this equation for this whole term, because we prove here when we put the n is equal to k, then we get this term, and this k plus 1 square write as it is, because here k plus 1 is not present, only k square is present. So plus k plus 1 square is equal to, now we little bit simplify this RHS also. So how we simplify? We write k plus 1 as it is, then we remove the bracket. So this k plus 1 plus 1. So this is k plus 2, or we write step by step k plus 1, k plus 1. We remove only the bracket of the k plus 1. Now this term is also simplified and this term is now. So 2 into k plus 1. So we multiply 2 with whole the bracket k plus 1. So we get 2k plus 2 plus 1. I hope you get. Now this divided by 6. So as we know the rule for the addition of the numerator and the denominator should be same. So we multiply and divided by this k plus 1 square with 6. So this k into k plus 1 into 2k plus 1 divided by 6 plus this k into k plus 1 square divided by 6. So this is nothing but this k plus 1 square, because when we cancel this 6 with 6, then again we get only k plus 1 square. But for we want to denominator same, that's why we take common 6 and convert this numerator denominator into a equal denominator. So again we solve this right hand side. So this k plus 1, this k plus 2, 1 plus 1 2, and this 2k plus 3, this 2 plus 1 3 divided by 6, and this term we write k plus 1, this 2k plus 1 plus this 6 into k plus 1 square divided by 6 is equal to, this term is right now as it is, k plus 2 plus 2k plus 3 divided by 6. Now this is our equation number 2. So now we prove this term, this LHS is equal to RHS. So keep it in your mind when we prove the LHS is equal to RHS and when not. So as I say, when we prove any equation, that time only 3 steps we perform. In first step we assume n is equal to 1, and that time we prove LHS is equal to RHS. But when we put n is equal to k, that time only we write the equation in k form. And now in this third step, when we put n is equal to k plus 1, that time we prove LHS is equal to RHS. So let's we start to prove it. LHS is equal to RHS. So LHS is equal to 1 square plus 2 square plus 3 square plus up to k square plus k plus 1 square. This is nothing but we prove here in the previous. Here we see this is our LHS, k into k plus 1 into 2k plus 1 plus 6k plus 1 square. So this is k plus 1 2k plus 1 plus 6k plus 1 square divided by 6. So when we prove any equation, that time first we observe LHS and the RHS carefully. What we want to find out, first focus on that term, means we solve the LHS, then the focus on the RHS. For example, in RHS we want k plus 1, k plus 2 and 2k plus 3 divided by 6. Now this is 6 is already in our LHS, so this is not need to fight for the denominator. Only we want to change this numerator into this form. So if we observe carefully, then here k plus 1 and k plus 1 we see. So as if we put k plus 1 common from this equation and take outside the equation, then this k plus 1 automatically we get, and then only our work is for the k plus 2 and 2k plus 3. These two terms we get easily. So let's we see how. So as I say, we put k plus 1 common from this equation, because this k plus 1 square is nothing but k plus 1 into k plus 1. So we put directly k plus 1 outside the bracket, and in the bracket only k into 2k plus 1 plus 6 into k plus 1 divided by 6. Now one term we find out. Now remaining two terms we find out. So simply we multiply this k to this whole bracket and this 6 with the whole bracket. So this k plus 1 into 2k square, this k into 2k square plus k plus this 6k plus 6 divided by 6. Okay, now this k plus 1 into 2k square plus 7k plus 6 divided by 6, because this k plus 6k 7k. Now this is the quadratic equation. We simplify this quadratic equation. So as I hope you know how we simplify this quadratic equation, and if not, then let's now we see. So this 2 into 6 is this 12 now, and this 7. So find out the term where the multiplication is come 12 and the addition is equal to 7. So find out these two integer number. So if we put 4 and the 3, so we got it 4 into 3 12 and 4 plus 3 7. So we write k plus 1 into 2k square plus 4k plus 3k plus 6 divided by 6. So k plus 1, this we now put 2k common from this two term. So this 2k, so in bracket k plus 2, because this 2k come outside, then this k. So this 2k into k, 2k square, and this 2k into 2, 4k, plus we put 3 common from this two term. So 3 into k plus 2, 3k, 3 into k, 3k, and 3 into 2, 6. So in this way we simplify the quadratic equation. Now this k plus 1 into this we put now 2 k plus 2 common from this whole bracket. So k plus 2, this 2k plus 3. I hope you get. We put k plus 1 common from the whole bracket. So this 2k k plus 2 take common, remaining 2k we write here. This k plus 2 take common, then this 3 is remaining. So in this way we write this equation and divided by 6. And if we observe carefully, then we get this is the RHS. So we can say LHS is equal to RHS, and hence we prove it. Now we see one more example. So this is 7 plus 13 plus 19 up to 6n plus 1 is equal to n into 3n plus 4. So as I say, we follow the 3 steps to solve this proof. First we consider n is equal to 1. So this is the RHS. First we solve the RHS. So RHS is equal to n into 3n plus 1. So when we put n is equal to 1, this 1 into 3 into 1 3, and 3 plus 4 7. Okay, and the LHS now. So this is all nothing but what? 6n plus 1, because let here if we put 6 into 1, 6 plus 1 7 we get. Then we put 6 into 2. So 6 into 2 12, and 12 plus 1 13. Then 19 plus this 19, how? 6 into 3 18 plus 1 19. So all this nothing but the 6n plus 1. And in the starting we put only n is equal to 1, not we go for the nth term. The n is itself 1. So at the starting our when we put n is equal to 1, the value is 7. So here we prove n is equal to RHS is equal to LHS. 7 is equal to 7. Now we move for the second step. So what I say, in second step only put n is equal to k, and nothing any need to prove it n is equal to k. This is for the we convert nth term into kth term. So this is the LHS, this is the RHS. Only we put k in the instead of the n. So this is 7 plus 13 plus 19, this is not 17, up to 6k plus 1 is equal to k into 3k plus 4. So now in the third step we put n is equal to k plus 1. Now here we prove LHS is equal to RHS again. So we write first our, as we know, the first equation is 7 plus 13 plus 19 plus up to 6n plus 1 is equal to n into 3n plus k. Now we put n is equal to k plus 1. So here 6 into this k plus 1. Now again as I say, k plus 1, but before writing k plus 1 we write k simply, then we increase by 1. So here only simply we write 6k plus 1. First our k is only k, and next time we increase by 1. So k plus 1 plus 1. I hope you get. First k is come, and then this k plus 1 come. First we write 2, then 2 plus 1 3 we write. As first 99 is came and then 100 is came. So in this same sense we write only first k here, and then we increment by 1. So then we write k plus 1. So this n we can write in k plus 1 form, and this plus 1 write as it is, this 6 write as it is, and this now RHS we converted into k plus 1 form. So this n is write as it is k plus 1, this 3 into k plus 1 plus, this is not the k, this is the 4 and this 4. So we write k plus 1 here plus this 4. So this is the term. I write separately because in my notebook some mistakes are there. We resolve it in here. So when we put k is equal to k plus 1, then as I say how we write the term. Now we solve this equation step by step. So we solve first RHS all. So this is k plus 1 into this 3 into k, 3k, 3 into 1, 3 plus this 4. So this k plus 1 and this one is 3k plus 7. This is RHS and this is the LHS. Now we put LHS. LHS is equal to 7 plus 13 plus 19 plus up to 6k plus 1 plus this 6k plus 1 plus 1. This is our LHS. Now we know this term. When we put k is equal to n is equal to k, that time we find out this term. Here we can see here, when we put n is equal to k, then 7 to 6k plus 1, the term is equal to k into 3k plus 4. So we put this term as k into 3k plus 4 and this RHS we write as it is. So this first term, this one is nothing but the k into 3k plus 4 plus 6 k plus 1 plus 1. Now we multiply this k with this bracket. So this is equal to 3k square plus 4k plus this 6k plus 6 plus 1. We multiply this 6 with the k plus 1. So 3k square plus 4k plus this 6k plus 7. So 3k square plus this 10k plus 7. Quadratic equation we solve it. So we, as I say, we want the multiplication is 21. 3 into 7 21 and the addition is the 10. So if we put 3 and 7, so itself it gives addition of 10 and multiplication is 21. So this 3k square plus 3k plus 7k plus 7. So we put 3k in common from this two term. So this 3k, k plus 1 plus we put 7 as a common. So 7k plus 1. So this k plus 1 common from this two term. So remaining is 3k plus 7. So if we observe carefully, then this is the RHS. So this is RHS. So now we say that LHS is equal to RHS, hence it is proof. Quickly we see one more example and then we move forward. So this is the question number 3. So summation of I is equal to 1 up to n, 1 upon I into I plus 1 is equal to n upon n plus 1. So the same, put n is equal to 1 for the step number 1. Then this is the RHS. So 1 upon 1 plus 1, 2. So 1 by 2. This is the RHS. And LHS. If we put, this is nothing but the 1 upon n into n plus 1. So if we put 1 here, then this 1 upon 1 into 1 plus 1 2. So again 1 by 2. So LHS is also 1 by 2, RHS also 1 by 2. I hope all you get idea. Now we move for this second step number 2. So this I, where this I is nothing but I start from 1 goes up to n, and then this equation is formed. So here we write step by step, means first we put I is equal to 1, then we write 1 upon 1 into 1 plus 1, then we write I is equal to 2, then I up to n. So this n into n plus 1. Now this equation we write in n form, because this is here in the form of I. We converted it into first n, and then in this second step we put n is equal to 1 and we write the kth form. So we see here we simplify this equation, means 1 into 1 plus 1 2. So this 1 by 2 plus 1 by 5 plus up to n into n plus 1. So we put n is equal to k now. So this is k into k plus 1 and this k by k plus 1. So here the second step is over. Only we write the equation in k form, not prove anything. Now in the third step we put n is equal to k plus 1. So as it is, when we put k plus 1, previously we put k simply and then we put k plus 1. So first we write 1 by k into k plus 1 plus 1 by k plus 1 into k plus 1 for the n term, and plus 1 is right as it is, because we see here this n we write in k plus 1, this k plus 1 plus 1. So now this plus 1 plus 1 now 2. So k plus 2 we write in the next step. So let's we see. And same for the RHS, this k plus 1 in the term of n, and this k plus 2. Why we write k plus 2? Because the n we put as k plus 1. So k plus 1 plus 1. So plus 1 plus 1 2. So here we directly write k plus 2. Now we prove LHS is equal to RHS. So this is the LHS. So 1 by 2 plus 1 by 5 up to 1 by k plus 1 plus 1 by 2 k plus 1 into k plus 2. So as we know the value of this, in second step we find out it when we put k is n is equal to k. So this value is nothing but k by k plus 1. We see here when we put n is equal to k, then this is equal to k upon k plus 1. So this value we put as k by k plus 1, and this term we write as it is because we don't know the value of this. So as I say, first let's make denominator equal. So for that we multiply and divided by k plus 2, because here k plus 1 already present, only we want k plus 2. So multiply and divided by the first term with k plus 2. So this k into k plus 2, and we directly write here plus 1, because now we change the denominator. Now our denominator are the same, so we directly write in combined form. So this k into k plus 1 divided by k plus 1 into k plus 2 now. Now multiply this k with the bracket. So this k square plus 2k plus 1 and this k plus 1 into k plus 2 as it is. So as I say, whenever we try to prove anything, then our previous, means the initial equation must be noticed. So we want to prove this equation. So in RHS side we want k plus 2 and k plus 1. So in this term already we have k plus 2. So we not disturb this term. We only think about the remaining terms. So if we observe carefully, then this is nothing but the quadratic equation of k plus 1 square. So this is nothing but this same again, k square plus 2k plus 1. So this term we see here. So we write here k plus 1 square. So this k plus 1 into k plus 1, k plus 1 square, and this is nothing but this original term. So k plus 1 into k plus 1. Now k plus 1 get cancelled and we get the RHS, k plus 1 upon k plus 2, and this is LHS is equal to RHS. I hope you all get idea how we prove any equation by using these three steps. Now we move further forward. So here two concepts are the important: clean star and clean closure. This is nothing but the sigma star, and this sigma means the string of the alphabet. For example, as we say A star. So what is meant by this A star? Means all the combination of the A. So this can be null, single A, double A, triple A, up to NA. So this is the A star. If we say A star, B star, then this means that A can be null, B can be null. So we get null only. Only A, single B. So this get we AB. Or this double A, single B. This can be possible. Or single A, double B. Single A, double B. Or double A, double B. Double B. This is nothing but the string. And in n number of combination of these two alphabets. Okay. Now A star plus B star. So what is difference between the A star into B star? Means here nothing but the, we can say, into. So A star, B star, and the difference between A star plus B star. This is nothing but the OR. A star or B star. So this is can be null. Let's suppose A star is also null, B star is also null. So this is null. Or A star only, means this A, single A, not B. Or not we consider both, only one A. Now second time we consider only B. So this is B. Again we consider double A only. Next double B only. So this is the combination of A star plus B star, not both. First if we take A, then only A. If we take B, then only B. Separated by comma, and this string write which combination you want to write. And this is means both are the needed. A star also, B star. So here we write A also, because let's suppose A is present and B is null. So that time this A can be come. And only B is also, single B is also come. So here when single A write, that time the B combination is null. So that's why we write A. And here B we write means A's combination is null. So this is the meaning of only A star, B star and A star plus B star. This can be any, means if we write A plus B and only A star, let's suppose, then how we write? Means from A plus B, any one is mandatory, because here star is not present. So any one symbol we write compulsory. So this A, and suppose this from the A star we write A, or only we write single A, that time this A is come here and this is the null. Or BA, from this A we write B, not A. This plus means or. A or B, we take B, and into this A, write compulsory. So this BA or BAA or AAA means this A from this first bracket and this 2A come from A star. So in this way we learn clean star. Now clean closure. This is nothing but A plus. The symbol of the clean closure is plus and clean star is star. So this is all the concept are the same. Only difference is here we not take null. We not assume the null value. We write here A, triple A, same, but not write null value. Now A star, A plus, B plus. This is again same. We take any combination of A, B, but not null is not allowed. So this A, B, if A, B, B, anything, any combination. Again this all rules which follow for the nil star is same for the closure also. Only difference null is not considered. So question number 2 is, in each case find a string of a minimum length in A0, means this symbol is now 0 and 1, not AB. This is 0, 1. Not in a language corresponding to a given regular expression. So what we write in A star or A plus, this is a regular expression, and what we write in this set means this null or single 1, single 0. In previous example we write null, single A, double A. So what we write in this set we separated by comma. This is this regular language, and what we write in the star or the closure plus, this is the expression. So if the question is write regular expression, then write in the form of this, and if the question is write the regular language, then write in the set and write the string separated by comma. Okay, now the first question, A star, 0 A star and 0. So I hope you know the meaning of this. 1 is compulsory, 0, 1 is also compulsory, and 0 is also compulsory. So first we consider all the terms are the null, means this A star is also null, 0, 1 star is also null, and 0 is also null. So always when the question is write the regular language for the expression, that time where we see first assume this term is null and then remaining term write. So consider all these are the null, so we write simply null. Now suppose 1 is present but both are the null, so only 1 write and these are two terms are the null. Then same for this term, means consider 0, 1 once and remaining 2 are the null. Then 0 consider, remaining 2 are the null. So in this way first 3-4 steps even we write, and then by write comma and dash dash dash, then also we get 1 mark, because we write regular expression and we write 2-3 terms. Means first we write null, then consider 1, then 0, 1 and 0. So 4 element we write in this set, and if we want write more, then consider this whole string once. Means both 1 is present, 0, 1 is also present, and 0 is also present. So this 1, 0, 1, 0. So next time we write 1, 0, 1, 0. Okay. Now 2 terms consider. So all the possibilities of this write, and in at the end write dash dash dash, means n number of string. So we write regular expression. Now we want to find out the minimum length of string which will not be accepted. So this see here 0, 1, 1. At any cost this 0, 1, 1 is not come in our string. Why? First thing, it end with 0, and if we consider this 0 is null, then also the string is end with 0, 1. And if we say this is also null, then only we consider 1 star, then also we take 1 double one, triple n, but not in front of this one we write 0 because string is not start from 0. So this 0 1 1, if we take any combination we not get this 0 1 1 combination. So for this equation we write any possible equation or the string which not accepted by this regular expression. So this is the question. Right, for this is the regular expression. I hope you all get idea. Now we write regular language for it. So RL means regular language. So as I say, first at the starting we consider all the equation as null. So we write null. But suppose this is the expression addition of 1, means here 1 is also present. That time we not put null here. Why? Because if we consider this expression as a null but 1 is present here now, so we not start the regular language with null value because that time 1 is come, but now it is not present here, so we consider null. Now second, only 0 we consider, and these two terms are the null. Then we put or consider these two terms null and only 1 we consider. Then only 100 is considered. Now 100 star. This is not 100 star. This 1 0 is compulsory and 0 star. And then this term star means if we consider this 1 0 right compulsory, because here we see 1 0 is compulsory and 0 star. So one time we write here 1 0 also because this 0 star is null. Then this 1 0 1 0 right because this 1 0 star is present, so we write this also. Then this 0 1 0 0 1 we write all possibilities, and this up to n. So this is the way how we write the regular language. We see one more example. This 0 star plus 1 star means if you consider 0 then not consider 1 because this is the plus means or. Same for second bracket 0 star or 1 star, 0 star or 1 star. Now let's suppose all the equation are the null. That time we get null. Then from this first bracket we consider 0. From this bracket we consider 0. From this bracket we consider 0. Then simply we write 3 0. Now from this equation we consider 0. From this we consider 1. And from this we consider 0. Then 0 1 0. Then consider 1 0 1. Means any combination you can write. Now we see which string at any cost we not get. So this string is nothing but the 0 1 0 1 or 1 0 1 0. 0 1 0 1 or 1 0 1 0. Why? Let's we see. Let's suppose we consider this bracket from 0. Yes. Then from this bracket we consider 1 and this bracket we consider 0. Then what about this one? This one from where it is come? Because if we consider, if you say we take 1 from this bracket, but already we take 0, so not again take 1 from this bracket itself, that bracket. So no. And same for this, if we consider 1 from this, 0 from this and 1 from this, and then 0 is come. Now what about that 0? Because from where this 0 is come? No. So this is the possible regular language which is not considered or accepted by this equation or the regular expression. I hope you all get idea. Now we see one more example or the question. Prove the following formula. So this is 1 1 1 star means this is a star for that one, and bracket star. So let's we suppose for the LHS is equal to, we write regular expression. This is the LHS regular expression is 1 1 1 star star. So regular language is equal to, this is 1 1 compulsory and 1 star we write many, means as you want you write. So first only I consider 1 1 and this 1 star I not consider. This is the null and this also null. So first consider null value because this whole bracket is null. Now only 1 1 we consider because a star is of this and I consider this is the null value. So only 1 1 is present. Then assume this 1 1 star is present. So if I put 1 1 two times, then this is 1 1, this is first time, and 1 1 this is second time. So this is meaning of that star. Now consider I want both three, this 3 1. So that time I write 1 2 3 and the this star I put 1 only. So only 3 star I write. I want now this 3 2 times. So this 1 is right 6 time now. 1 2 3 1 2 3. The power. Star is nothing but the power. So first we assume this power is 0. Then we assume this power is 1. I hope you all get the idea. So in this way this regular language write for this regular expression. Now we put RHS. So the regular expression is 1 1 plus 1 1 1 star. So the regular language for this expression is, regular language, first we consider this is the null. When we put null star for the 0, that time we put this is the null. Now we consider this star is 1 and from this we write only 1. You write 1 1 or write 1 1 1. So first I suppose this is the 1 1 1. Second time I suppose this 3 times 1, not this one. Then consider I want to put a 1 1 and the power is 2, means I write 1 word 2 times. So this is 1 2 3 4. This is for the first time, this is for the second time. So this 4 times. Then suppose I want only write this 3 1 at the 2 times. So I write 6 times. 1 2 3 first time, 1 2 3 second time. So if we observe carefully, then the LHS is equal to RHS we see, means this null we get null, this 2 times 1, this 2 times 1. If this is 3 times 1, so here is also present 3 times 1s. If 4 times 1 is present, so here is also 4 times 1 is present. So in this way we prove this regular expression is equal to this regular expression. I hope you get idea how we prove this regular expression. Now we see one more example. A star B star whole bracket star is equal to null or A in bracket A plus B star or B. So LHS, let's suppose now this is LHS and we consider this is the null because whole bracket star. So first we, as I say, first consider this star as null. So we put is null. Then if we put star as a 1, then this only A is present. A and B are the compulsory and this A star and B star we can take null as well. So let's suppose at the starting my A star is null and this B star is null. So A and B we write, because this is not this star, so we not put as a null, and this is star. I suppose first time I assume this is the 1. Now let's suppose this A and this A, this star is nothing but first time I put 1, so this A and B, and now I assume this B star as null, and that so I write AAB. Then only assume A, this A star is a null value. So A, B, B. So I hope you all get idea what we do here. So in this way we write regular language for the LHS. Now we write regular language for the RHS. So the regular expression for the RHS is null or A into AB star or B. So meaning is for this expression is as this is null or this term, this string. So first we consider null, second time we consider that this is this string. So this A is compulsory, this B is compulsory, and A or B, or you put A then not consider this B. If you consider this B then not consider this A. So first starting we put this star as null, then we write AB. Now let's suppose we consider this A. From this bracket we only consider A and this B, then again we write AAB. Now next time we assume this AA, this BB, then only we consider this A, we not consider this that A, and this B and B. So as we see here, our LHS regular language and the RHS regular language are the same. So from this we can say from our equation number A and from equation number 2 we say that LHS is equal to RHS, and hence we prove it. So I hope you also get idea how we prove the regular expression as well. Now we see the next question. So here we want to write regular expression and the regular language for the given statement. So statement is the language of all string containing exactly 2 zeros. So for that statement we write first regular language, always first write regular language, and from this we write regular expression. So all the possibilities we write in the regular language. A statement say the language contain all possible string. So this string exactly 2 0. In this string exactly 2 0 is present. Okay. So all this possibility we write. So first null is not considered because we want only two zeros compulsory in this string. So we not consider the language as a null, because if we put null value then 2 zeros are not present in our language. So only first time we consider 0 0. Then possibility is 1 0 0. Here also 2 0 are present and exactly 2. So we can say 0 1 0 or then 1 0 1 0 or any string up to infinity. So this is the regular language. Now we write regular expression. So how we write? First we write 2 0, which are the compulsory. Then the possibilities are 1 is come front. So we write here 1 star. We see here 1 can come in front of 2 zeros. So we say 1 star here. Then second possibility, 1 can be come at the middle of the 2 0. So here is we write 1 star. Now the possibility is 1 is came after 2 zeros, or we say 0 0 1. This is also possibility na. So 1 star. So now we check this regular expression gives us the same result of the regular language or not. So suppose at the starting all 1 are the null. So only 2 zeros are remaining. So this 2 0 we write here. Now suppose this 1 is, we take 1 and these 2 are the null. Then we get 1 0 0. So we get here. Then we want 0 1 0. So this 0, this 1, and 0, and these two 1 are the null. Then again, if we consider that this string, then this 1 we consider, this 0 consider, then again 1 consider, 0 consider, and this one is the null. So all possibilities are we cover here in this regular expression. So for that, this is the regular expression for that regular language, and this regular language is gives the result of this statement, the language of all string containing exactly 2 zeros. Now we see more example on it. So the next statement is the language of all string containing at least 2 zeros. At least 2 zero. More than 2 zero is also allowed, but at least 2 zero is present in the string. Only one single 0 is present is not allowed. So again we consider first time only 2 zeros are present. Next 1 and 2 zeros are the present. Next time 3 zeros are the present. Means more than 2 or more than 2, not only 1. Means only 10, 1 0 or a single 0 is not allowed. So again we write first zeros, then we write here 1 plus 0 star. Why? Because if we consider 1, then we write here 1, these two terms are the null, then 1 0 0 we get. Then let's suppose from this bracket we only consider 0, that time 0 triple 0 are the come, so this is also allowed. So for that we write 1 plus 0 star 0, 1 plus 0 star 0, 1 plus 0 star. Means any string which contain 2 0 compulsory, and remaining this string is null also, or any combination of 1 0, and for same for this and this bracket. So I hope you get idea. Now we move for the next question. The language of all string that do not end with 0 1. So it is clear that this string can be end with 0 0 or 1 0 or 1 1. So starting, as I say, start with regular language. So this string can be end with 0, can be end with 1. So first we consider 2 0, means only one single 0 is also allowed. Then 1 0 0, this 1 0 0 1 0 end with 1 0, here end with 0 0, end with 0 0. Any string can be allowed, but this string which contains 0 1 at the end, this is not allowed. So here is the three possibilities. 1, this string can be end with 0 0 or 1 0 or 1 1, but 0 1 is not allowed. So for that we write one bracket. Then in front of this string, any combination of 0 or the 1 are the allowed. So for that we write 1 plus 0 plus 1 star, means any combination of 0 and 1 you can take, and only end with this string, means 0 0 or 1 0 or 1 1. This is the compulsory. You take any string compulsory from this bracket, or you take 0 0 or you go for 1 0 or 1 1. So same for here. The next question, the language of all string that beginning and end with 0 0 or 1 1. This equation we solve by own, means some idea you get. If any confusion is in your mind, then we solve it. So let's we solve in another page. We write first regular language. So as the statement say this string that beginning and end with 0 0 or 1 1. Okay, so we write regular language, means let's suppose the string is beginning with 0 and any can. any string we put. Let's suppose starting beginning is with 1 1 and end with any string. Then suppose this 1 1 0 1 1, this is also allowed because what we want beginning and end with 0 0 1 1. So here 1 0 1 0 is not allowed because this is not start with 0 0 or 1 1 and not end with also 0 0 or 1 1. Then this 0 0 1 0 0 is allowed. Again if we say this 0 0, then 1 0 1 0 and 1 1, this is also allowed because starting and end with 0 0 or 1 1. So at the infinity combination can be formed. So now we write regular expression RE. So as the statement say, the string can be start with 0 0 or 1 1, and this can be more than one time, means 0 0 come with 4 times, 6 times, anytime. So for that we write 0 0 or 1 1 star and end with 0 0 plus 1 1 star. So this is for the beginning, this is for the end. Now middle is any set of 1 and 0. So we can say here 0 plus 1 star. You put 1 times 0, 2 times 0, 10 times 0, or as if you want to put anything different than 1 1 0 0 1, any string is possible. So I hope you get the idea. This is also allowed, or you simply write here 0 0 plus 1 1, 0 plus 1 star and 0 0 plus 1 1. No, not need to write star because here this is cover, means any combination of 0 and 1 you can put. So instead of preferring this, I think you prefer for this because it is clear from the statement you want to start 0 0 and or 1 1. So again then 2 times 0 or 4 times or 3 times any combination is come, then this 0 plus 1 is covered, these zeros. So for that I think this is the correct regular expression. I hope you all get idea now. We see one more example. The language of all string containing both 1 1 and 0 1 0 as a substring, means in the language 1 1 is compulsory. We can see here this 1 1 is compulsory and 0 1 0 is also compulsory for this string, and then remaining any combination of 1 or 0 is allowed. This if we see here, then first 1 0 1 is come and then 1 1 is come, means any combination is possible of 1 and 0, but condition is it compulsory contain 1 1 and 0 1 0. So for that we write regular expression. How we write? I teach you. So this 1 1 and 0 1 0 always the string contain. So we first write regular language. So this is can be 1 1 0 1 0 simply, then 0 1 1 0 1 0 or 1 1 1 0 0 0 1 0, any combination, but this is the compulsory. Or say 0 1 0 1 1 0 1 1. So we see here, we see regular expression. So first we want 1 1 and 0 1 0 compulsory in the string. This is true. Then here any combination of 1 0 can be possible, 1 or 0 and star we write because any combination of 1 and 0 we write in front of this. Then any combination of 1 and 0 can be write in the middle of this two string. Okay, and end also any possible set of 0 and 1 can be possible. Okay, so this is for when 1 come front of the 101. We can see here first 1 is come, then 0 is come. Here is also first 1 is come, then 0 string is come. But if this string is like first the 0 is came and then 1 string is came, so this is also another possibility. So for that we write, once you write one possibility, this string is came, or here write we, or the possibility of 0 first come and 1 come second, and then all string write as it is, 1 or 0 star, 1 plus 0 star, and 1 plus 0 star. So these are the two possibility. So I hope you all get idea now. So I hope now you solve this question number 8, because here the regular expression is given and only you want to write regular language. And now I hope you all able to write regular language. Once one question we see also. Let's suppose this is the first question, 0 star 1, 0 star 1, 0 star 1 star 0 0. So what I say, first consider all star as a null. So this is null, this one compulsory, null, but at the starting I consider this whole bracket is the null, and this is also null, then only 1 is came here. Now let's suppose this 1 is compulsory, this is the null, and this 0 star is also null, and 1 0 star is also null, only 1 is remaining here, and this is the compulsory for this bracket, only that bracket. And bracket star means 1 I can write multiple times, so 3 times I write here. So here we write, then in the same sense I write multiple regular possible languages. We see one more. Let's suppose this bracket is my null, this bracket is my null. This is not null because here bracket star is not right. So, okay, so as you want to write 0 or 1 star 0 star or 1 star 0 star 1 star, so first time I write only 0, not this remaining equation. So my regular language is like 0 first, because these are the null. Let's suppose second time I consider 1 here from this bracket. From this bracket I consider 1 0. So 1 0, this is possibility, and this is the null. Next time I consider this is the null. From this bracket I consider here 0 1. This 1 star I consider null. And from this 3 I consider this, so I don't think about this because this is the OR symbol, so only I think about from these three string, only one string I consider, so I consider this, and from this string I consider 1 star, and 1 star is my null, so only I put 0 here. So this 0, then I suppose I take 1 from this string and I write 2 times 1, this is also possibilities. Then 0, this 1 0, from this 00 I put, then 1, let's suppose this time I put whole this string 1 0 1, from this string only single 0 I consider, so any possibility you can write here. So this is the regular language for this big substring, but is only see the for the length it is big, but when we simplify or understand the meaning, then it is too simple or the understands easily. So I hope all you get idea how to prove the equation, how to prove regular expression, how write regular language and the regular expression, and all the possibilities. So today we stop here. We see how to draw DFA, NFA and remaining all these concepts of the TOC in the next video. Thank you.